Hey guys and girls, and welcome back to another simple science and technology video. And in this video, we will be kicking off our series of ICT systems with hardware. And more specifically, we'll be looking at internal hardware, the kind of hardware that is critical for the operation of computer systems. So things like CPU, RAM, internal hard disks. So things that are critical and basically computers cannot operate without them. We're not looking at things like peripherals like keyboards, mice, monitors, because frankly, you'll find out that computers won't need them to operate. We need them to interface with computers, okay? So things like CPU, RAM, motherboards, these are critical things that are required for computers and ICT systems to operate. So last week, we had a brief overview of what an ICT system was, and it's essentially a setup or an organization of four key things: hardware, software, data, and users. So in this video, we'll be looking at the first one of these focuses, and it's hardware. Okay, so hardware is a collection or a physical parts or components of a computer system that are directed by software to execute commands or instructions. So essentially, these are the tools that that software uses to execute its instructions and commands. Okay, so these are the physical components that you see when you interact or look at computer systems. So these are the physical components, yeah? But physical components require brains. They require the software in order to direct them to execute, in order to direct them to work. Okay? So hardware needs software, and today we'll be looking at the physical part of this relationship, and that's hardware. Okay. So hardware is best understood as two different types of hardware groups. So, firstly, you've got internal hardware. So, these are things, as I said, which are critical for the operation of computer systems. And as such, they're typically cased inside a computer system or a particular unit, as you'll see later. And that's why they're called internal. These are critical things. So, imagine a human body. These devices, these hardware that are internal, are like your organs, your heart, you know, things that you need in order to live. Whereas external uh, hardware are essentially things that you use to interface with your computer systems, things that you use to either input information into your computer systems or output or display them, display the information from your computer systems. Think of these as like clothing, hats, clothes, your sweatshirt, for example. You don't need them to live, but it helps you convey who you are. Okay? So, as I said before, internal hardware are components which are crucial for the operation of a computer. These are typically connected directly onto what is called a motherboard, which we will discuss in the next video, and they're typically contained within the computer's main body or case. So that is where we can physically see the difference between an internal hardware and external hardware, is basically whatever is in the casing. And whatever's in the casing is typically what is essential for operation. In other words, it's not casing's there for you to basically not pull it in and out very often. So it's meant to be in there. It's meant to be in there for an extended period of time. Okay, and the whole point of internal hardware as a concept is that we see internal hardware as things that make up a computer. When you think of a computer, you must have internal hardware, and the computer is the internal hardware that it is composed of. Whereas external hardware, or it's typically known as peripherals, are essentially devices that I said are used to interface with the computer, to input information or to output information from a computer. So these things are like your printers. So as I said, it's an output device in that it helps you display in a printed form the data from your computer. Either it would be from a word processing software like Microsoft Word, or it could be, for example, a mouse. It's used to input your commands from left clicking, right clicking, and move your mouse around. Monitor to digitally display your information, keyboard likewise, to input using the keys. And they're typically connected to external connectors within your computers or computer systems. So things like your lightning ports, your USB-C ports. You've got your SD card ports here, your HDMI ports, and your Ethernet cable ports in order to connect with the wider network. So these things are external hardware because they're connected externally to the computer, and the critical thing here is that you don't need them specifically to operate. Yeah. Okay, so these external ports, you can see them on the side of your laptop that you're using to watch this video, or on the PC. It's either on the front lower side of lower part of the PC, those docks, or it's on the back. You always find them on the back. Very sophisticated bunch of ports, and those are external or peripheral connectors. So connectors are another word for port. And in this video, we'll be focusing on internal hardware. So let's look at what internal hardware is composed of. Let's have a wider review of those before we dive deep into each of the individual components. So firstly, you've got your CPU. This is essentially the brains of the computer. This is where most of the calculation takes place. Of course, there's and also video processing that's done by the GPU, but on the CPU, mainly all of billions and billions of calculations take place, and these calculations are essentially decoded instructions from memories such as RAM, and essentially all of the instructions and all the code that needs to be executed in order to get things done, in order for applications to run, happens at the CPU. Okay, it's known as a central processing unit, and we'll talk about it in detail later. So think of it as the brains of the computer. It's like a human brain in that it is where the decision making takes place. It's where the decision making is centralized. Okay, so it is a central processing unit. It's typically one of the most expensive parts of the computer. And then you've got your internal storage, and these nowadays are mainly your HDDs and your SSDs, hard disk drives, and solid state drives. So anything from files, images, videos, your application data, things like databases, and even your operating systems are stored on internal drives, so HDDs and SSDs. And the key here is that whatever is stored on here will be kept on the HDDs and SSDs even when the power goes off. Okay, so this is where RAM shows its difference. So RAM is essentially a type of memory that is different to HDDs and SSDs in that whatever's stored on the RAM, once the power goes off, the data is essentially lost. And this is why RAM is extremely powerful, in that RAM can be used for a caching purpose, in that your CPU essentially requires instructions in order to execute. And where does it get its instructions from? From a memory location. So it could be from internal storage. However, data access from the internal storage into the CPU is not quick enough for us to get things done in the modern day. As a result, we need a quick access data or memory location. And this is why you need a type of memory that can be quickly accessed, but only on a temporary basis. Okay? And that's where random access memory comes in. And that's where RAM is extremely useful for a purpose called caching. And nowadays, most applications run on RAM and are very, very dependent on RAM, especially games. Okay, so RAM, caching. Link those two together and you will always understand and see the difference between RAM and internal storage. Next, you've got ROM. ROM is read-only memory, and do not get mixed up with ROM and HDDs and SSDs. Do not get mixed up with ROM and internal storage. Okay, both of them are classified as permanent storage in that when power goes off, the data on internal storage devices and ROM will still be there. But the key difference here is that read-only memory is strictly non-rewritable, whereas internal storage memory is rewritable, as I mentioned many times before. So essentially, the data that is stored in ROM is burnt into the chip at the manufacturer level. So essentially, at the factory, they've burnt data onto the chip, onto this piece of firmware, essentially so that you cannot go ahead and rewrite the information on the software, on the ROM. So essentially, it's like your DNA. You're born with the information of that is your DNA, and it's not meant to be changed. Okay, and what is then stored on the ROM? Typically, it's configuration data for computer systems. You'll hear things like BIOS, things that you'll see on the startup of your computer before you hit the operating system, and it's stored on a permanent basis. Yeah, in the sense that it's literally burnt into the chip and cannot be rewritten. Okay, so it's like your DNA. And then you've got your sound cards, and these are essentially devices and integrated circuit boards that are responsible for the production of sounds in the computer. Similarly, you've got graphics cards or video cards, and these are responsible for processing and transfer of video data to the viewing device like monitors. So these are actually quite similar to CPUs. Actually, they're called GPUs, graphical processing units. And they're mainly acting as a CPU but for video data. Okay. Now, finally, to link everything together, you've got your motherboard, and that's the main platform where all of these devices come together. It's a printed circuit board. You print a circuit boards, like in electronics when you're building your automated systems, and it basically allows for all of these devices, and in many cases, including external devices, to communicate like a hub or like a mother bringing together her child devices. So, as you can see, when it comes to internal hardware, you've essentially got 7 key devices that you need to understand in depth, in some sort of depth, of their operation. And typically, in almost any device that you see nowadays that has some sort of display that you can interact with or humans can interact with, they need all 7 of these devices. Okay, and today we'll be focusing on the main top 3. That is the CPU, the HDDs and SSDs, and the RAM. Okay, and in the next video we'll be talking about the other 4. So firstly, we have the CPU, or the Central Processing Unit. It's the hardware that is responsible for taking, interpreting, and executing instructions from your program. So it executes code. Okay, and the process in which it executes these, it goes ahead and does its job is fetching, decoding, and executing. And I personally recognize that a lot of educational systems do not go ahead and teach in depth about the CPU processes and the CPU cycle. And I just want to mention briefly about these key processes because they are critical. And these processes operate on every single devices with CPUs in the world. Okay, and we need to understand this, and we need to understand it in a simple and understandable and memorable way. So, firstly, you need to know that CPU is, you could understand it as a very, very super powerful calculator. Okay, because from whatever is decoded to the execution stage, the CPU essentially calculates machine code. Okay, it is given instructions by the RAM to calculate machine code. It's a very, very powerful calculator. Okay, let's look at the CPU cycle, the fetching, decoding, and running processes. These are the 3 main processes that take place at the CPU. Okay, so firstly, the process of fetching involves the CPU fetching instructions from programs from the RAM. Okay, we'll talk about RAM later. But RAM is essentially, think of it as a memory location where instructions are stored on a temporary basis. And the CPU mainly talks to the RAM to get its input. Okay, so it gets instructions from the RAM. Okay, and the instructions from the RAM is now stored in the CPU's memory location known as an immediate access RAM. So it's another type of RAM that's different from the RAM that it's getting instructions from. So the instructions from the RAM the diagram on top there, is stored in the CPU's RAM. Okay, so as you can see, almost even things like your GPU and your sound cards and your video, they have RAM. Okay, so your CPU has RAM as well. Okay, the instructions are then passed into what is known as an instructions register in your CPU, and that essentially acts as another layer of caching in order for your CPU to execute things on a quicker basis. Caching allows for things to happen quicker and it reduces delay time in these connections, okay? And then you've got decoding. And this process takes the instructions from the instructions register into an interpretable form. It sort of decrypts this information into interpretable form so that it can be executed by the CPU or the ALU unit in the CPU. Okay, and the thing you need to know is that when it comes to executing, the ALU, which is the executing unit within the CPU, can only process machine code. As a result, whatever instruction that is received at the instructions register must be understood by the arithmetic and logic unit, the ALU. Okay, and these are typically things, arithmetic calculations. Okay, ones and zeros, binary stuff, or hexabit, binary stuff. Okay, and whatever is calculated is released as an output to the devices that it may impact. Okay, so the executed instructions, as I mentioned before, can involve things like basic arithmetic, comparing numbers together, and moving them around in memory. Okay, and as a result, these calculations are very simple, but they must be understood by the ALU. So that's why you need your decoder process. Okay. Now, these calculations take place, billions of times per second and per CPU, and it's absolutely insane. As a result, I want you to remember the CPU as a super duper fast calculator. Okay. Now, as you can see here, there are two components that are critical for the data flow inside the CPU, and these two components make up the control unit of the CPU, and these are the decoder and the multiplexer. As you can see, it links up the key channels within the CPU, okay? And that allows it to basically dictate the flow of data within the CPU. So pretty much the two most important parts of your computer, your CPU, is your decoder and your multiplexer, because that allows for the balance and flow of information within your CPU and allows it to operate effectively, okay? So those two components form what is called a control unit. The CPU is also known as a microprocessor nowadays, as is a difference in the past, in that in the past CPUs were made of very many different units, integrated circuits that are connected within a circuit board, but now it's a single integrated circuit. So that's why it's called a microprocessor all-in-one. Okay, now CPUs are found in all devices and mainly for control and monitoring purposes. Okay, so whatever thing that has control. So control means you can dictate the output of another device, or to monitor, to gather input, you need a CPU. Okay. Next, you've got your internal storages, and nowadays it's typically your HDDs and SSDs. HDDs, or internal hard disk drives, and solid state drives, SSDs, are the computer's main storage devices. Okay, they are capable of storing a huge amount of data, especially when it is compared to any type of RAM. Yeah. And they can store everything, things from files, text, photos, and images, databases, application software, operating systems. Okay, your boot up operating systems are stored on HDDs and SSDs. They are known as non-volatile or permanent storage, meaning that the main key thing here is that when power goes off, the data will still be stored. So that's where it's different from RAM. So let's look at the difference between the two by firstly looking at HDDs. HDDs are a form of magnetic storage media. Where does the magnet come from? It consists of a disk or a platter, okay, a magnetic platter because it is coated with a magnetic material such as nickel. Okay, the disk itself is made of ceramic, glass, or aluminium. And HDDs are known as electromechanical devices because it involves a spinning disk and it's powered by electricity, and electricity flows through it, so it's an electromechanical device. And that's where its reliability is a bit of a problem compared to SSDs, which are purely electronical devices. Okay, so how an HDD works is that the coating element that's on the magnetic disk can be magnetized. In other words, the elements within the disk can flip in direction. Okay, as you can see here in the diagram that I've magnified from the disk here, you've got red and blue elements facing in opposite directions, and those are basically different magnetic directions, and those represent ones and zeros. Excuse me. And the magnetizing is done by a device within the HDD known as the read-write head. It's one of those, like it's one of those needles that go down, and it's similar to those old music playing devices. Yeah, and those that head there with that needle is responsible for reading and writing onto the disk, okay, or from the disk. HDDs are used to store everything, and it's mainly nowadays for fast retrieval and storage of data. Regardless of what you think compared to RAM or SSDs, HDD data access is actually very, very fast. Okay, yeah, much faster than a lot of other storage devices, and they're used in real-time systems. As a result, things like robotics or online systems for ticket booking or file systems, even in servers. Actually, they're preferred to use in servers than SSDs, and you'll find out why. Advantages are that of course, they have fast data transfer and access rates. Okay, not as fast as SSDs, but it is very, very fast. And of course, fast or not is relative, but compared to other storage devices in the day, it is fast. Okay, and it's got large memory capacities. These things go up to terabytes, man. And you've got disadvantages, however, in that they can be easily damaged if not correctly shut down. Okay, it leads to a phenomenon known as head crash, and that essentially loses the data stored on your HDDs. Sadly, they've also got moving parts, as I mentioned before. As a result, they are less reliable than SDs, which do not have any moving parts. So why would that be less reliable? Because you've got a mechanical element there. So for example, if something gets stuck within the mechanical operations of the disk, your disk is faulty then, okay? So it's not just an electronical failure that can go wrong, a mechanical failure that prevents the disk from running, you know, um, efficiently will effectively stop your system from running. So there's more points of failure, potential failure. And finally, it's noisy. Okay, you've got a spinning disk, and that generates vibration noise. No, SSDs, they serve the same functions as HDDs. They serve what internal storage devices are meant to do, to store everything on a permanent basis as long as power is turned even off. Yeah. Okay. So they serve the same purpose, and instead of spinning disks, you've got NAND chips that are used and are stuck onto your SSDs. They look very, very similar to RAM, which is also um, static. There's no moving parts. And these devices are quickly taking over HDDs. They serve the same purpose, but instead of spinning disks, they've got static chips known as NAND chips. Okay, and these chips basically consist of millions of tiny transistors, which essentially store ones and zeros, and that's sort of like your HDD disk elements that go up or down in the magnetic direction. And as a result, they create a type of read-writable memory that's volatile. And effectively, this forms a non-volatile read-writable memory. Okay, and the advantages of an SSD is that it is reliable. There are no moving parts. So there are no points of mechanical failure. It's lighter, thinner, and cooler. It's like a RAM. And that makes it more suitable for use in a laptop. You know, your HDDs are pretty thick. So in comparison, you've got SSDs which are very, very thin and can be slotted very, very neatly into modern day laptops, which must be portable for use. Okay. They consume less power than HDDs, which means it is more economically beneficial. They are thinner, lighter, and cooler. Okay, mentioned. Um, Due to the lack of a mechanical component, there's no need for the disk to start spinning at the operational velocity for the device to operate optimally. So, startup time is negligible. You don't have to wait for these disks to start spinning. Once you boot your operating systems on, it goes. Okay, so also they run at a temperature much cooler than HDDs, again, further explaining their preference use in laptops. And finally, they allow for faster access, um, data access. And that is the key performance benefit that justifies why SSDs are more commonly used than HDDs. Okay, however, there is a main disadvantage of SSDs, and it's got to do with the technological state as of right now of the device, and it's known as SSD endurance. Excuse me. Due to their durability, the operation of most SSDs are conservatively limited to only about 20 gigabytes of write operations a day. And as a result, they are actually not used in internet servers as prevalently as HDDs because, in terms of durability, HDDs are more durable. So you've got your balance between durability and reliability. But eventually, this durability problem will be fixed, and SSDs will be prevalent in servers everywhere in the world. And finally, for today, we've got RAM, which is essentially an internal chip that allows for caching to take place. It's a middleman where data can be stored temporarily to be quickly accessed by the CPU. And it temporarily stores data of applications currently and part of the operating systems that are in use. So it's all about data that is currently in use within the session, within the instance. And I'll give you a very, very clear example of how RAM works with internal storage. Okay, but firstly, you need to understand that data can be written or read from the RAM just like your internal storage is. But it's read at a much faster rate and it's read in a volatile basis. In that, when data is stored on RAM and the power goes off, everything is deleted. So let's look at an example of how RAM operates. So let's say you're trying to create a Word document and your internal storage device stores the Word application, right? So what happens is when you go to create a Word document, it copies an empty document onto the RAM. It copies the application software and the empty document onto the RAM, okay, which will then open on your client computer, on your client monitor when you go ahead and press it. And let's say you make you type a sentence or add some images to the Word document. Essentially, what you're doing is you're adding a few bytes of Word or your image data onto the RAM. So it doesn't go directly to the internal storage yet, okay? And when you go ahead and click save, when you go ahead and make that change, it goes ahead and updates your document view or whatever you see on your screen. So your RAM here not only processes your request of typing or adding images, it also updates you with whatever you need to see or basically responds to your request. And when you go ahead and press save, it then stores your progress onto the internal storage. It stores your saved file onto the internal storage. So remember, when you use Word, you are not directly saving onto the internal storage until you press save. Whatever you're seeing on the screen is due to your RAM storing and updating and responding to your request on whatever you're writing. So what happens if you do the same process, but now you power off your machine before you even saved? Of course, that means you can't save, right? Because whatever's stored on your RAM now will be deleted. So you can't go ahead and save it. So that is why in recent days, Microsoft Word has gone ahead and implemented a autosave process that detects an abrupt shutdown to allow for data to be saved onto the hard disk. And only when you go ahead and choose that autosave the next time you restart your computer, it will actually redisplay whatever work you've done and did not mean to shut down. Similarly, let's look at gaming. So when you start up a game, let's say Modern Warfare, you load it onto your RAM. Okay, your internal storage device doesn't go straight up to your display, and it you don't directly interact with your internal storage. You go ahead and open your internal storage. Let's say when you're in your game, you shoot your enemy, yeah? When you're actually shooting, what you're doing is you're requesting a shot to take place within the game, okay? Within the application of the game. So what that does is the RAM will respond to you saying, okay, you've done your shot. There's an image, or there's a process of you recoiling from that shot. So the RAM updates your game process, okay? And this RAM could be that RAM stick, or it could be the RAM from the GPU. But either way, it's from RAM, okay? And when you go ahead and finish, let's say, your mission, so after this loop of shooting requests and updating the game temporarily for you, only when you actually save the game progress do you actually store anything on your internal store on a permanent basis. So that's why they always recommend you to save, okay? Because only when you prompt the save, unless there's autosave, do you actually store anything on a permanent basis on your internal storage. Okay, so that's all for RAM, CPU, and HDDs and SSDs today. We'll be looking at the other remaining four internal hardware devices on another time. Okay, thank you very much for your attention. I hope this has been useful, and I'm gonna try to set up quizzes for you guys. So um, you know, check out the description whenever it comes. And I hope you all have a wonderful day. And thank you so much for your support.